Good morning, this is Brent with Lykins Motorsports. This is a World Products 8200 deck small block Ford block. This is going to be the basis of a small block Ford tunnel port road race engine build. So we've talked about this for a little while now, and finally got some parts in, and we're making a little bit of headway. The block is fully machined and ready to do some detail work on and get going. So you'll see more of this here in a little bit. It's a 4155 bore cast iron block, 302 mains, 8200 deck. Already done some detail work on it. Chamfered the bottoms of the cylinders. You don't want any sharp edges there. These are laid over really nice, and that keeps you from peeling back aluminum on the pistons. When you start doing that, then you start seeing some score marks on the pistons, and you don't want that. So really beefy block. As you can see, it's got my cart sway backed. These are a little chunky, but they are very robust, very stout. You want a block that will not flex when you're trying to make horsepower. But we're not going to do any detail work here because this is a dry sump engine, so we'll be putting one of our block off plates here. We got some Durabond HP cam bearings, coated cam bearings that we'll be knocking in. And so let's step back and do a little bit more generalizing here. So this is a tunnel port small block Ford. I've done one of these engines for the same customer, Mr. Mark, and we did a street build that did really well. Little over 300 cubic inches, and made some good horsepower and just looked really nostalgic and unique. So we're deciding to do a road race motor with those with similar heads, except they are the race heads. So the valve sizes are the differences between the tunnel port street heads and the race heads. In addition, the way that the rocker arms are mounted is different. The street heads use a rocker arm stud. The race heads use like a shaft mounted deal that you would see on an FE, where the oil comes up through a special passage in the block. Since we are using an aftermarket block, we're using T&D paired rockers for this. So I've had those in here for a bit, and we'll oil through the push rods, so everything will be a little bit different than factory. 4155 bore. The crank is 3.385 stroke. We've got some 5.4 inch Dyers rods. These are very high quality rods. These are what a lot of circle track engine builders want for their race engines that they build. The crankshaft is custom Bryant, all rim polished. Again, billet steel, very beefy as well. The camshaft, since we're dealing with the tunnel port heads and the push rod tubes, where you don't have a lot of room, what I've decided to do is keep a lot of the factory geometry correct, so that we don't have to start modifying heads with oval shaped tubes and this and that. So we're going to use a billet steel core solid flat tappet camshaft, and it's a steel cam. It's not a cast iron cam like we're traditionally thinking of when we think of flat tappet cams. The lifters are some PPP tool steel lifters that have been DLC coated, so they are hot swappable, no break-in period. This is what the Cup guys used to run before they switched over to solid rollers. So this will allow me to keep all the geometry the same, since the original engine was a solid flat tappet. So we can keep the lifter height the same, and that will allow all the geometry from the pushrod cup in the lifter up to be the same, so we can get our pushrod centered in those pushrod tubes. So a little bit of thinking that went behind all of that. The cam is ordered. I'm having Bullet grind that cam for me. They're actually making a core and then grinding the core. So that'll be probably about a 2.5, 3 month process. You have a little bit of a lead time. I'm in the process of checking bearing clearances. So we're using these calico coated rod bearings. If you don't recognize that part number, this is a Honda rod journal diameter. So a 1/888 diameter journal, very small for low bearing speed, and just some really fancy and high dollar parts in this engine. So I'm going to go ahead and I was in the middle of checking rod bearing clearances. I ran out of bearings last week because needed some X bearings. I didn't have any on the shelf, so I'm mixing some standard and some X bearings to get around a 2-inch, not a 2-inch, a 2,000th rod bearing clearance. 2-inch would be tremendous, but 2 thou rod bearing clearance. So it's around 1/9 to 2,000. So with the smaller rod journal diameters, you can use a smaller clearance. We'll use some modern oil in this engine. So I'm gonna go ahead and get the rest of my rods, the bearing clearances checked, and I've already checked out the rod bolt stretch. So Dyer's rods wants us to, these are ARP 2000s bolts. They're 7/16 in diameter. They need to stretch somewhere between 5/1000 and 5/1000 4/10, and mine were coming in. I had to go up to this 70 pound-feet to get 5.3 and 5.4, so that's what we're going to keep on headed for. And we're going to stretch all these bolts, check them with our ARP stretch gauge, and get all of our rod bearing clearances checked. And then we're going to knock some cam bearings in and put some mock-up main bearings in and drop our crank on the bearings, and then check out our rod bolt to cylinder clearance. These blocks are very, very beefy in the bottom end. If you remember all the fiasco that we went through on our 464 cleaver, we had to clearance everything but the air filter. So I'm assuming that this will maybe be the same. They've got some pretty thick reliefs from the factory. We'll see how those line up. And then we'll get the engine on the engine stand. Again, this is a dry sump engine. So what we'll be doing, all these drains from the lifter valley, boom, 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 boom. We're going to put some standoffs in there. If I could figure out a way to scavenge from the intake valley, I would do that. But the way that the intake manifold is made, I don't think I can do that. So we'll need to put some standoffs in there so that if something happens and the oil level gets too high, that it would still drain down into the block or into the crankcase. The intake manifold is a 2x4 factory intake, and I've already sent that to Bobby Crumpley of Houston Vapor Blasting. We're going to make that thing look like new. So you'll need to stay tuned for future episodes of this engine build so that you don't miss out. In the background, JJ Jr. ready to go. I've got a dyno session planned for Monday morning. You guys have been saying what's going on with Triple J, so we're going to do that. This iteration will be the dry sump oil pan. So I want to see what the difference is. We got some valve covers on there that don't have breathers, so we'll make as much vacuum as we possibly can. And I'm taking the cam with me that I had ground. So we'll see what the difference is between the Motorsports E303 cam and the Lykins Motorsports custom hydraulic roller. So Monday will be a very long day, but maybe a very rewarding day. So I'm going to go ahead and finish up my rod bearing clearances, and I'll check back with you in a second. All right, so I made it a little bit further, and actually on my last rod to check, everything's coming in good with that. I switched over to Main bearing clearances. Main bearing clearances are good, but for some reason I didn't have a full box of bearings, so I'll have to order some more. This is why we mock up stuff before we do anything, so you think, oh, this crank spins really nice, until it gets to this point right here. Chunk. So I'm gonna have to clearance that, and it's just enough to lock things up. If the crank is moved forward, if you push it back, it'll clear. So it won't take much. But what that has allowed me to do is to check our rod bolt clearance. So this is something that you can do with just a rod cap and a bolt. And you just roll the crank over and just make sure that you have adequate clearance in between that cylinder and the rod bolt. And I've already checked all of these, and there's no possible way. I mean, there's a long distance in between there, and they were all about the same. So we won't have to do any clearance work on the bottoms of our cylinders. So I'm gonna get this clearanced real quick. Just hit that with a die grinder and make sure our crank doesn't hit it, and then we'll get to putting our cam bearings in. Okay, little die grinder action, and we are good to go. So I'm turning the crank over. I don't hear any other noises. Taking the thrust in and out just to make sure that we don't have any more clearance issues, and we are good to go. All right, so we're going to put cam bearings in before we do our final wash. I always like to wait and do the final wash until after those goes in, because you'll always have a little bit of shavings or something that'll roll off the bearing, and I just like having everything sparkly clean. These are the Durabond 351 HP bearings, because the cam tunnel on these aftermarket blocks, they're not always like the factory 302, 351 blocks. So if I remember correctly, the cam tunnel bore is the same diameter all the way through. So that means the OD on all of our bearings are the same, but the ID will be different. So small block Ford cams are tapered from front to back. So the ID on the back bearing will be smaller than the ID on the front bearing. These are not grooved. They are coated on the inside. They are not grooved. Our bearing housing is not grooved, so the hole has to line up with the hole in the main saddle. All right, the bearings are in. This is actually JJ Jr.'s cam that I just slid in here to test, and you can see I've got a hold of it by the snout, and this thing turns like butter. That's what we want. We want some butter. So I am good with that. Go ahead and knock in the rear cam plug, get it on an engine stand and get it washed, but I think I will do that later. I'm gonna take the day off, the week off, and hang out with the family, do some cool stuff. So we're gonna stop right here. I'll put that cam plug in, pull this cam out, and we'll be ready to rock and roll. So thank you very much for hanging in with me on this video. This is going to be a really cool build, all top-notch parts. Got the pistons coming. Diamond did not have any head models to make pistons, and I'm not cool on shipping very expensive heads back and forth for them to do a mold on. Race Tech had the model because Randy Gillis, who used to be their sales manager, he passed away a couple years ago, maybe last year. He was a hardcore Ford guy, so he had all kinds of head models and everything. So we went to Race Tech for the pistons. Those will be they'll have all kinds of cool tricks, lightning procedure done on those, crown coating, vertical gas ports, DLC coated tool steel wrist pins for our dry sump, metric ring pack. So they will be top notch, and I'm looking forward to seeing those here after a while. But you don't want to miss out on any of this. I don't really expect this to be a barn burner in terms of horsepower. If we make 550 to 600 horsepower, I would be ecstatic. And the heads flow about 280 CFM. Exhaust port is about what you would expect from a factory Ford exhaust port. The cubic inches will help tame that big fat intake port. And we've got a cam coming that will snap that valve open and get that air fuel intake charge moving quicker. So we will do the very best that we can possibly do with this engine, and it'll be a nice runner. So you don't want to miss out on it. Hit that subscribe button so that you don't miss out. And with that, I will say adios. Y'all have a good 4th of July weekend, and I'll catch you next week with some JJ Jr. dyno results. See ya.